for you as well. 6.3 talks about locating real zeros of polynomial functions. Our goal here is we want to learn the rational zero theorem and we want to learn applications of it. So in other words, our question here is how do we find the zeros of a polynomial p of x if we cannot factor it easily? So you have quadratic equations that are easy to factor. And if they haven't been easy to factor, you can use what formula if you want to solve it? Quadratic. Good, you can use the quadratic formula. Once you get to a third degree polynomial or higher, it may not be as easy to factor it. And if that's the case, then the rational zeros theorem comes in handy. Okay, remember, if you need to send a message, go out in the hallway. So if you have a polynomial of degree, what's the degree here of this polynomial? N, very good. If you have a polynomial of degree n here with integer coefficients a sub n, which are non-zero, then any rational zero of p of x must be of the form f over q, where f is a factor of the constant term. So f is a factor of the constant term, a naught. So you find the factors of your constant, that gives you f, the possibilities for f. And then the q is a factor of the leading coefficient a sub n. So again, to find the possible rational zeros, or to find the possible zeros, rational zeros, of a polynomial of degree n, you find the factors of your constant term, divide them by the factors of your leading coefficient. So you're going to see a plus or minus because you have the positive and the negative of all of those. Does that make sense? I need responses.
Can you repeat?
Go ahead. What's your question?
Can you repeat the last part?
Sure. So whenever you have to find your rational zeros, the possibilities will be plus or minus because your factors are plus or minus, right? So that's why you can include those. So you will take the factors of your constant term divided by the factors of your leading coefficient. That's how you find the possible rational zeros. Okay? So things that this does not do. The rational zero theorem does not necessarily find even a single zero of a polynomial. Instead, what it does, it helps you identify a list of the possible rational zeros, those that are possible. There'll be a long list, okay? And then you have to do it strategically, choose one, and then go and determine whether it's a zero or not. And to determine whether there's a zero or not, you can use synthetic division, okay? Another note, it does not say anything about irrational or complex zeros. It only helps you determine whether you have rational zeros. If a polynomial has zeros that are either irrational or complex, then you have to use other tools to find them. Okay? Rational zeros theorem. What does it say A naught is?
I don't know what that sign is. Zero?
A naught? A naught is what? So what is this? What kind of term is A naught for a polynomial? For a given polynomial, what kind of term is A naught? What does it say? A constant term. Good. So it's a constant, right? Do with the smaller numbers? Some helpful hints here. After finding your possible rational zeros before you begin trial and error, because that's the process here, consider the tips below for choosing possible zeros. Start with your integer values. And because you're choosing rational, you have the possible rational zeros, you expect to see what kind of numbers? Zeros, yes. What kind of zeros? What's the name of the theorem? Rational zeros. So some of the zeros you expect to be what? Rational numbers, which are the same thing as? Fractions. Very good. Fractions. So you want to begin with the integer values. The synthetic division and resulting quotient will usually be simpler than whenever you try fractions. Begin with values near 1. That will help keep the numbers in the calculation smaller, which will allow you to test values a bit more quickly, okay? So we're gonna go through a few examples. We're not gonna do every example in this section because they test the exact same concept, okay? So g of x is equal to negative 2x cubed plus 11x squared plus x minus 30. So again, g of x is equal to negative 2x cubed excuse me, plus 11x squared plus x minus 30. What are the factors of a naught? Let me ask this question. What is a naught? What's a naught equal to for us?
0.
A naught is 0? What does a naught represent? I see you flipping back to the rational zeros theorem, good. So for us, what's a naught? Negative 30, very good. It's negative 30. What is the factors of a sub 3? Or not the factors, let me just ask, what is a sub 3? Negative 2, very good. So what you may see, you may just notice that a naught is your constant term. A 3 here, because this has degree what? What's the degree of this polynomial? To the third is 3. Good. So the leading coefficient will always be a sub whatever is the highest degree. So a sub 3 is equal to negative 2 here. So now we have to determine our factors, okay? Now your factors are the numbers that divide into 30, or that negative 30 is divisible by, okay? So you automatically have plus or minus. Then we go through the list, right? Factors of negative 30. Is one a factor? Yes. Is 2 a factor? Yes. Is 3 a factor? Yes. Is 4 a factor? 4 goes into 30? 4 goes into negative 30? No. Okay, so 4 is not. Is 5? 6? 7? No. What other numbers? 10. Good. Good. 30. Good. That's it. So note that you have plus or minus, and then you put the set of all, you list those numbers. And this, we have the plus or minus because you can have positive or negative, right? And we normally go from lowest to greatest, okay, or lowest to highest. So factors of a sub 3, what do we put outside? Plus or minus, good. And then what numbers? 1 and 2, excellent. Okay, so remember the rational zeros theorem says we take what for F and what for Q?
Q is the factor and
Q is the factors of what?
of the leading coefficient.
Ah.
And F is the factor of the constant.
Good. So this is our, and we can point it out over here as well. That's our leading coefficient. So that represents what? Q or F? Q or F? Q, good. So then we'll have F is the factors of A naught over Q, which is the factors of A3. Good morning. Help yourself to snacks if you would like. They're in the front. Okay? You're welcome. So factors of A naught, So technically outside, we have plus or minus, right? And then we have the set of all numbers. Now, check this out. You would take all of these numbers and put it over 1. Then you would take all of these numbers and put it over what? 2. That's it. That's it. Okay? So, this is plus or minus 1 over 1 is? 1. So if you take anything divided by 1, you get? You get 1? You get the number, right? So tell me what to list.
Wait, 1 over
2, 3, 4, 5, 6, 7, 8.
3, 4?
I mean, the same numbers 5, 6, 10, 15, 30.
Good. So that consists of taking all of these numbers and dividing it by 1. Now what do we have? Yes?
1 subtracted by 10. Right?
Say what?
You do 2 divided by 2.
Which is? Is it already in the set? Yes. So do we write it again? No. Good identification, good observation. What's next?
2 over 3.
3 over 2. Good. Remember, we're taking the factors of A0 and dividing it by the factors of A3. Okay? Good. So notice this is why I put, because if you're highly visual, so just an observation, if you're highly visual, it helps to put the factors of your constant term on top, divided by the factors of your leading coefficient, because then you know this goes in your numerator, this goes in your denominator. That's a visual cue. Okay? What's the next one? Say it loud. Good. Keep going.
You already have 3. The 6 over 2 is good.
Right. That's you already got 5 as well. Good.
And 15 over 2.
So put 15 over 2. Okay. Anything else?
And then that's it, because 30 over 2 is 15.
And it already appears. You got it. So that's it. That's it. So here, what we've done is, it says, for each of the polynomials, list all of the potential rational zeros. So far, that's what we've done. All of the potential rational zeros is this set right here. This gives us, so this set is a list of all potential rational zeros. Are we done? No, because what does it say we need to do? Good. It says we need to find the actual zeros, right? So we need to find the actual zeros. So to find the actual zeros, remember the hints up top says choose an integer. So I'm going to avoid the fractions right now, and I'm going to choose an integer. And I'm going to choose one of the smaller ones so our numbers aren't really large. Okay? So you can start with 1, and this you're doing by trial and error. You can start with 1. You'll find out that 1 does not work. Okay? Then you start with 2. Okay? I'm going to write out. Say it again.
Does 1 always not work?
No, it just doesn't work for this specific one. That's a good question. And again, we're trying this by trial and error. Okay? So good. So we're going to do 2. We're going to use synthetic division because notice that we want to find our actual zeros. Synthetic division, if we find a 0, we know our remainder is going to be what? 0. Good. What's the degree of this polynomial? Third. So it's 3, right? So once we do synthetic division and find a 0, the resulting coefficients will be the coefficients of what degree polynomial? To the second. Good. And you know how to do what to a second degree polynomial? You know how to factor it. You also know how to use a quadratic formula to solve for it, right? So you will use synthetic division to help you find a 0. You can factor it from there on out, and then you'll have your zeros. That is what this section is all about. Okay? So, what do we write here?
-2, 11, 1, and -3.
Good. Walk me through it. Good. To get Good. Add.
7.
Good. Multiply.
14.
13.
You get 13?
15.
15 because you have to do what?
Add.
Add. Good.
And then 30. So the remainder is 0.
You get 30. Add it, and that leaves you with
0.
0. So that's our remainder, which means what about 2? 2 is a factor or 2 is a what? And I'm glad you said that. What? 2 is a 0, right? Good. So if you want to factor it, and the reason why I'm going over the factoring, because whenever we get to the section where you have to factor a polynomial completely, we will have done it already. Okay? I see your hand. Hold on one second. So because 2 is a 0, that means what is a factor? 2 is a 0. So this means 2 is a 0. And what is a factor? Can't hear you.
Is it 1 and 2?
No. Whenever we say 2 is a 0, what does it mean to, what's the corresponding concept for a factor?
The responding y coordinate is 0.
No, not the corresponding y coordinate is 0. Think back to 6.2. Whenever we had synthetic division and you had a polynomial divided by another polynomial and you wanted to see if that number was a 0, what did that mean about that polynomial? It was a what? What you're dividing by, what was it? We went over one at the beginning of class. If 2 is a 0, what is a factor?
X plus what? Oh, it's negative 2, right? Negative 2 squared. I'm looking at 6.2.
Not negative 2 squared.
Negative 2.
Negative 2? You just said 2 was a 0 here. So that means what is a factor?
X minus 2.
X minus 2. Very good. X minus 2 is a factor. That means X minus 2 is a factor. If you do not remember anything else, remember that, okay? Because it helps you factor a polynomial completely. Once you have a 0, it means X minus that 0 is a factor, is a linear factor, okay? So, and X minus 2, a factor. Okay? So, go ahead and ask your question.
Oh, you answered it.
Okay. All right. So, these coefficients here are the coefficients of a what degree polynomial? 2. Good. What is it? What is the polynomial?
Negative 2x squared plus 7x plus 15.
Plus 15. Okay? Which we can factor. So that's negative 2x here and x there. Or you can use what? Quadratic formula. Either one. Either one works. I'm just going to factor it because I want you to also, I'm doing extra information, is factor the polynomial completely. So negative 2x times x gives you negative 2x squared. We need two numbers that multiply to 15, but when we use these combinations that we've already set up, we'll get negative 2. Well, let me say that again and say that correctly. We want two numbers that whenever we multiply them, we get 15. But when we factor in the fact that this coefficient is negative 2 and this is a 1, we want our middle term to be 7. 5 and 3? Okay, good. It's 5 and 3. So now we need to figure out how. We know this is a positive, so it can either be 5 and 3 or it could be negative 5 and negative 3. It's a trial and error. Okay, you choose it and check it. Okay, so it turns out that this will be minus 5 and this will be minus 3. Okay, if you tried +3 and +5, you'll see that when you check it, you do not get this. That means you go back to the drawing board. You can either change the 5 and the 3, or then you can put the -3, -5, or -5, -3. So you would have 4 things to check. Does that make sense? Yes? No?
Yes.
Okay, I see heads nodding and answers yes. Okay, so just to check it so you can see it, we use what method? What do we do to check this? We use what? FOIL, good. So first, -2x squared, outer, plus what? Outer gives us what?
Negative 10x.
-10x, positive 10x. Inner gives you what? -3x, good. Last gives you 15, plus 15. So then you check, you get -2x squared. What's 10x minus 3x?
7x.
Good, so plus 7x plus 15. So it does indeed work. That is the factorization. Remember, if you need to send a message, go out in the hallway. But that is how we factor it. Okay, so what does that mean? What else do we need to find? What's our goal? Can't hear you. What's the problem say we need to find? It says, then write the polynomial in factored form and identify what? The actual zeros, right? So if we're writing the polynomial g of x in completely factored form, what goes here? We have x minus 2 times what? We just put what? Does everyone know what it means to have a polynomial in completely factored form? See head shaking? No. So let's talk about that for a second. If you have a polynomial of degree 3, then you should have 3 linear factors. And by that I mean factors that all have x with the power of 1. Okay? So for example, this is a linear factor. So whenever we have a degree 3 polynomial, our hope is that we have 3 linear factors. So that means g of x would be x minus 2. We ended up with a degree 2 polynomial, so our other 2 linear factors would be what? Good. And x minus 5. Good. Okay, so this is not this question, but if we have a degree 4 polynomial, how many linear factors should we have? 4 linear factors. If we have a degree 5 polynomial, how many linear factors should we have? 5. If we have a degree 7 polynomial, how many linear factors should we have? 7. Good. Okay, so that means the process is a little bit longer. I'm not going to give you something of degree 7 and ask you to factor it completely. Okay, that's just tedious, and it's fine, but it's important that you understand the process. Okay, so what we did was we factored this in factored form completely, and now what we also have to do is identify what? The actual zeros. Good. We identify what is a zero already. What do we identify as a 0 already? 2. Very good. 2 is a 0. So now to find the other zeros, what do we have to do? Can't hear you.
Set the factor form, like how much do we have to 0?
Do we have to use this whole thing?
No.
No. What can we use? X minus 5 and? Negative 2x minus 3. You already found 2 is a 0. So now you just use the factors from your degree 2 to to find the remaining zeros. Very good. So you have negative 2x minus 3 equals 0. And then you have x minus 5 equals 0. And so this means negative 2x equals what? 3, because you add 3 to both sides. Then what do? Divide by negative 2, good. To get x equals what? Negative 3 over 2. And here we do what? Get x equals 5. Good. So these are our other zeros. Notice that they appear in the list, right? They appear here. They appear, or it appears here, and we also get 2. Okay? So you write it in a set form. So just to answer the other part of the question, we write down our actual zeros consist of is the set consisting of negative 3 halves, 2, and 5. Doesn't matter the order in which you put those numbers. I tend to put the smallest numbers first, but as long as they're in the set, that's your solution. What questions do you have? Okay. What questions do you have? Okay, so let's look at another example. Let's look at another example.
So, would it be 1 or 2?
Yeah, it says begin values near 1. So take a minute. Determine the factors of A0, the factors of A4, A sub 4, and the possible rational zeros. And then we'll do the rest together. We have to factor the polynomial, that's our goal, and our other goal is to find the actual zeros. But to get there, we need to find these. Okay? What's A0 for us? 50, good. What's A sub 4? 1, good. So go ahead and take a minute to identify the factors of 50, the factors of 1, and the possible rational zeros. And once you've done that, check in with your neighbors to confirm. So the factors of 50 are plus or minus what? 1, 2, 5, 10. What else? 25, right? Because if you divide it by 2, 2 goes into 50 25 times. So be careful. And then what else? 50. Good. What are the factors of 1? Just 1? What should we always have? Plus or minus. Good. Always have plus or minus. Always. For the possible ones, we always put plus or minus. So tell me the possible rational zeros. Plus or minus.
1, 2, 5, 10, 25,
And 50. Like that? Yes. Put those brackets, right? Good. Very good. Okay. So, what number you want to try first? 5? What was the hint? What was one of the tips? Go back and look at the tips. What were the helpful tips? Say it again. Oh, what do you want to start with? 1.
Oh.
Right? 1. Let's not skip 1. Sometimes 1 will work. Sometimes it won't. Okay? So let's try 1. And again, remember you have plus or minus, right? But we're going to try the 1. So what do we put in our first row?
1, 23, 25,
Good. Now, synthetically divide. What do we do?
Bring down one.
Go.
1 times 1 is
Talk loud. I'm writing.
1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2. 23 plus 2 is 5. Damn, someone else.
Watch your mouth.
Oh.
Now you in the video saying that. Watch that. Go ahead. Add, you get what? Go ahead.
50.
Oh, yeah. So, that means what is a 0?
What?
1 is a 0. 1 is a 0. And here, our polynomial we said is r of x, right? So that means r of x, whenever we factor r of x at this stage, is equal to x minus what number?
1.
1. Good. Tell me the polynomial that's left. Tell me the polynomial that's left. What do you use? You can do it. What do you use? We divide it.
You can do synthetic division again.
But wait, I'm just asking for the polynomial that goes here.
Ain't it 2? Sorry, not ain't it, but
It's all good. I'm with you. I'm with you.
2x, right, plus
No? Where are you getting that from?
outside.
You were talking about what?
1, 2, 5. 1, 2, 2, 5.
Yeah, but you skipped 1.
Oh, I thought it was right. Okay,
Man, we just don't like one today at all.
So what?
X cubed
X cubed. Go ahead.
plus 2x squared
Yes.
plus 25x
Yes.
plus 50.
Plus 50. Excellent. So you used these coefficients to write your remaining polynomial. We good?
Tie.
Yeah. We good? Okay, so now we have what degree polynomial we have to figure out the zeros for? Third, right? So again, we go through this again. Absolutely. Absolutely. So notice that what we're doing at each stage, whenever we approach it this way, whenever we get to a degree 2, we will only need to find how many more zeros once we get to a degree 2.
Oh, 1. Wait, 2?
2, right?
Yeah.
Okay, so you can go through and you can choose whatever number you want to. We chose 1, 1 worked. You can choose -1, you can choose 2 or -2. Just for the sake of time, we're going to choose -2. Okay? Just for sake of time. So -2. Then, what are the coefficients that we use?
1, 2,
Good.
25,
And 50. Good. Notice that you're using the coefficients of the degree 3 polynomial. That's important. So let's go through and synthetically divide. We brought down to 1. Keep going.
-2,
-2 times
Zero.
-2.
0. No, that's 25.
-50.
0.
0. So that means what? -2 is a 0 as well. Good. -2 is a 0. Which means we can now write r of x as what? What's missing? X minus 1 from above, right? We have to make sure we include that. So this x minus 1 stays forever now. So x minus 1 times what?
X plus 2.
X plus 2. Good, because -2 was a 0. And then what do we have left? Mm-hmm. Plus 25. Good, because the coefficient of x is what? Coefficient of x is 0. Very good. So that 1 came from here. 0 means there's no x. And there you go. So now we just have to factor what? X squared plus 25. Good. So let's factor it. So x squared plus 25 There's no x term. So we can use the square root property here to solve. So if we set that equal to 0, that means x squared equals what? 25. Positive or negative? Negative, good. And now what do we do to both sides?
Square root.
Good, take the square root of both sides. Hey, but you're taking the square root of a negative, which means what is involved? I, very good. So when you take the square root, how many answers do you get? 2, excellent. Plus or minus what? 5i, excellent. So those are our remaining zeros. So I'm going to put our zeros, well, yes, I'll put our zeros highlighted in red. 1 is a 0, -2 is a 0, and these are zeros as well. Does the colors help? No?
Yes.
Oh, okay. These are zeros. So notice that we can leave it like this. So our actual zeros are, you tell me.
1, -2.
Or you put -2.
You can put -2 first if you want to.
Plus or minus. How would I? Is it just plus or minus I or?
Plus or minus I? Plus or minus 5i, good. So you can either relieve that as plus or minus 5i, or you can write positive 5i and then a negative 5i. Okay? Now, to completely factor this into linear factors, then you have your zeros right here, right? So we can use that to write r of x. R of x is going to be x minus 1 times x plus 2 times x minus 5i. And what's the last one? X plus 5i. That's it. What questions do you have? What questions do you have? Okay. All right, good. You want to do the back to that previous problem, notice that we were able to solve that and get the complex numbers. Okay, what other questions do you want? Just to make sure you're good with it. Q of x is equal to x cubed minus 10x squared plus 23x minus 14. Find the factors of a naught. Find the factors of a sub 3. Find the possible rational zeros. So, what's a naught? Very good. -14. And what's a 3? A sub 3? 1. Go ahead. I'll give you 2 minutes. Once you've done that, go ahead and finish it. You're at a point now where you can finish it. Good. So we have our factors of -14 are plus or minus the set consisting of, go ahead.
1, 2, 7, 14.
1, 2,
7.
and good. And then the factors of 1. Good for you. And then the possible rational zeros. Is that right? Curly brackets, good. Okay, and then you said you tried 1. You synthetically divided. What was your first row?
Bring down
Good. And so then when you synthetically divide, you bring down your 1. Keep going.
1, 2, 1 is 1. -9 times 1 is -9. 14.
Good. So that's your remainder. Very good. So then that told you that Q of x factors as x minus 1 because 1 is a 0. This means 1 is a 0. And then you have the coefficients left give you the following polynomial, as you told me it's what? 1x squared if you want to write the 1 there. Go ahead.
Minus 9x plus 14.
Good. Okay, so again, these correspond to what the coefficients you had left. And now the only thing left to do is to factor this degree 2 polynomial. So you want two numbers. You want two numbers that multiply to give you 14, but add to give you -9. -7 and -2. Good. So this is now x minus 1 times the quantity x minus 7 times the quantity x minus 2. That's how you factor it. Are we done? Partially. What's left? The actual zeros. Very good. Your actual zeros. So we have to finish because we found 1 was a 0. But now we have these other two factors right here. We have these other two factors here where we have to find those zeros. So you would have x minus 7 equals 0, and then you'd have x minus 2 equals 0, which means x equals what?
7.
And x equals?
2.
Good. So 1, what are your other zeros?
7 and 2.
7 and 2. That's it. And q of x is equal to this. You did very well. What questions do you have?
Are the actual zeros always gonna like somehow match the factors in the A naught? The actual zeros of the numbers that are in the A naught.
No, they're going to appear, so not just in A naught. In this case, they appear in A naught because A sub 3 is 1. However, they will appear in the possible rational zeros list. This list, they will appear from this list. Now, mind you, notice in the previous example, we had 2 zeros that did not appear in this list because the rational zeros theorem only gives you the set of possible rational zeros, so integers and fractions. But if you have irrational numbers and complex numbers, they don't appear. They do not appear in this list. And that's okay because if we have, all right, excellent. That's 6.3.